All right, folks, so here is a recap on today's lesson. This is going to be a very short lesson because it's very easy. We actually did most of the legwork of today's lesson yesterday in creating the equation for a slope and then plugging in the x value for the slope that we want at that x value. So let's pretend we're trying to find the slope at this tangent point, at this point tangent right here. And we're trying to find the slope of this green dotted line on the bottom, okay? Now, this point looks more like 3 comma positive 1, but just in this hypothetical case, I'm going to call it 3 comma negative 1, even though that's not visually accurate, okay? So let's say we did the same process we did yesterday of using the limit method to find the slope at the tangent point, and we got 3/4, okay? All we're going to do is use this red formula, which is called point slope form. Okay, it's called point slope form that you learned from IM1, and apply these three values into the slope formula. So we're going to put the 3/4 in for m. Okay, m is the same thing as f prime of x. We're just calling it f prime of x in calculus. Okay, I'm going to put this 3 in right here, this -1 in right there, and we get these values at these locations. The double negative turns to positive, we keep the right side the same, and we subtract 1 from both sides. And if you want, you can distribute the 3/4 to the x and -3, and then combine like terms with the resulting -9/4 and -1 to truly get a y equal to mx plus b equation of a line. So ultimately today we're applying this point slope form right here in red, and then inserting the values into the orange highlights on right here, and then creating essentially what is a y equal to mx plus b equation of this green dotted line over here. Okay, and it truly looks like y equals to mx plus b after distributing the 3/4 and combining like terms with the resulting -9/4 and -1. Okay, so that's basically today's lesson. Now, if it asks you for the normal line, as that normal line means perpendicular line, which is this black dotted line right here. Okay, and remember, perpendicular means 90 degrees. So all you would do in that case is you would take the 3/4 and flip it, okay, and change the sign, which in this case it changes from a previous positive to a negative. Boom, boom, and boom. And there is your equation of the black dotted line going downhill, so to speak. Okay, so let's run through some quick examples, just really quick, just to look at it. Okay, we don't need to get too deep because this is basically what I covered already as the gist of today's lesson. So let's say we have a function that looks like this right here. Okay, so this is our function. Okay, we're going to use the same method we did yesterday right here. Okay, I don't need to go through the specifics of this algebra because we literally did something very similar yesterday, just with different numbers. And so now you get the equation, the formula for the slope at any x value, but we don't want just any x value. We want it at x equals to 1. So we plug in 1 into x here and x here, okay, and we get a slope of, okay, -1/18 after plugging in 1 into x here and x here. We get -1/18. So that goes into your, okay, let's get this right here. Let's get that queued up. So that -1/18 goes in right here. All right. And then we have an x value of 1. Okay. So we have x value of 1. And let me delete this over here. Delete this. Okay. And let's delete this right here. So we have an x value of 1. Your question might be, what is the y value? Well, let's plug in 1 into the original equation of f of x, okay, to find the y value. 1 plus 5 is 6. 2/6 is 1/3. So we have an x value of 1 and a y value of 1/3. Okay. So I'm going to plug in 1 into x sub 1, and then 1/3 here. Okay, so I got these 4 excuse me, these three orange highlights get plugged in into there, okay? And then you just basically simplify. You can just basically leave it like this, okay? And then plus 1/3. Okay? And that's your equation of the line, okay? This was the slope of the tangent line at x equals to 1. This is going to be the equation of the line at the tangent line. So specifically speaking, it is this equation of this blue line that is tangent at x equals to 1 to the red graph. Okay? And it's basically the same exact concept here, okay, just with radicals, okay? So we're going to use the same here. Over here, we're going to use the same idea. Well, I don't really need to go over this example because it's exactly the same just with radical. We use the same idea here, okay, to find this formula for the slope, okay? And over here, since it's asking for 1, okay, so we got the formula slope right here, okay? And we plug in 1 for x, okay? And this right here basically becomes this right here. And we get negative 1/3 for the slope. And then we plug that in, okay? We plug that in to this red equation, okay? The negative 1/3 gets plugged into the red equation over here. And then we need the point, okay? So I plug in this 1, okay, into this right here, and I get 3, okay? So I plug in this into x and get 3 for the y coordinate. So now these 3 oranges get plugged in over here. The 1 gets plugged in here, the 3 gets plugged in here, the negative 1/3 gets plugged in here. Now in this last example, they hooked it up for you. So instead of doing this whole limit thing right here that we did yesterday, okay, this whole limit thing that we did yesterday, they did it for you and they gave you this 18x plus 6 is the slope formula for this original f of x, okay? So now if you want the slope at x equals to 2, you plug in 2 into this and you get 42, okay? All right? And then, so you get the slope, which goes in right over here, okay? Whoops. So the slope goes in for m right here. And then you plug in 2 into f of x to get 49, okay, the y coordinate. And this 49 goes here, your 2 goes here, and you just proceed as usual, okay? And then you just add y sub 1 to both sides and you get your final answer, which is right here, okay? Which is right there. Okay, thanks for tuning in, folks. That's today's lesson, short and sweet.